Hi there, my name is James Rolfe, and in this video, we'll be talking about node voltage method or nodal analysis. To begin, we'll discuss some rules that are crucial to understanding nodal analysis. First, voltage in a wire only changes when encountering a circuit element, in most cases, a resistor. Second, the voltage drop across a resistor can be calculated by subtracting the voltage before the resistor from the voltage after the resistor in the direction of the current flow. Or you could think of it as the positive polarity end minus the negative polarity end. With these rules in place, let's go through a simple example. First, we'll recognize that the voltage drop across this resistor can be measured using VA minus VB. Next, we can recognize that there are no elements between the voltage source and VA. So VA is equal to 15 volts. Now we know VA, so all we need to calculate the voltage drop across the resistor is VB. We can see that in this example, there are no circuit elements in between VB and ground. So VB has to be equal to the ground voltage, which is always 0. Lastly, we simply solve for voltage drop using VA and VB. VA is 15, VB is 0, so 15 minus 0 is 15. This means that the voltage drop across the resistor is 15 volts. Now, let's move on to a real problem. So here is an example of a problem that you may be asked about in class or on a quiz. So here we have a problem where we have to calculate V1, V2, and V3 using nodal analysis. So the first thing we can do to start off that we do with any equation, we want to mark the polarities. So for this one, we can just have positive, negative, positive, negative, positive, negative. And then so that indicates the flow of current. So for this one, the flow of current would be going this direction. For this one, it would be in this direction, positive to negative in this direction. So this is the current flowing through V1. So we can label it I1. And then same with this one, this can be I2. And this can be I3. So now we have the directions of current. So now the next step is to write V1, V2, and V3 in terms of nodal analysis. So for V1, we want to take the voltage before it minus the voltage after it, right? So before V1, we have this 15 volt power supply. So the beginning would be 15 volts. This node right here, we don't know. So this one we can label A. So writing V1, it would be V1 equals 15 volts minus VA. Next, for V2, same thing. We take the voltage before it minus the voltage after it. We can see that this voltage down here is grounded, so the voltage here is 0. So for V2, it would be VA minus 0. And then for V3, we're looking at the voltage before it, which we can see here is also VA, and the voltage after it, which is also grounded. So V3 also equals VA minus 0. So now we have these three equations. The next step is to take a look at each labeled essential node. In this case, it's only VA. So we want to do KCL at each labeled node. So in this case, A, so we want to look at the current flowing in versus the current flowing out. The current flowing in, I1, the current flowing out, I2 and I3. So if we perform KCL at node A, we get I1 equals I2 plus I3. Now, if we use Ohm's law, V equals IR, we can rewrite this in terms of voltage and resistance. So let's do that. We get V1 over R1 equals V2 over R2 plus V3 over R3. Great, so now we have this equation. Now we can see that we have R1, R2, and R3 given in the problem, and we have V1, V2, and V3 written in terms of VA. So if we plug all of these in, our only variable is VA. So then we can solve for VA. So let's do that. we have, let's use a different color. V1 equals 15 volts minus VA over R1, which is 2 kilo ohms, equals V2 over R2, which is VA minus 0 over 6 kilo ohms, plus V3, which is VA minus 0 over 4 kilo ohms. Now you'll notice all of these denominators have a common denominator of 6. So we can multiply this whole equation by 6 to simplify out these denominators. So if we multiply this out by 6, this section becomes 6 over 2, which is 3. So 3 times 15 is 45 volts minus 3 VA, which equals, multiplying 6, we just get the 6 cancel out, so it's VA plus 6 times 4 times VA, or 6 divided by 4 times VA, which would be 3 halves VA, or 1.5 VA. So if we take these and add these together and move this to the other side, it's VA plus 1.5 VA, so that's 2.5 VA plus 3. So that would be 5.5 VA equals 45 volts. So now we just divide this 5.5 from both sides, and we get VA equals 8.18 volts. Great, so now we have VA, and now we can take that VA and plug it into this equation and get V1, V2, and V3, which is what we're looking for. So let's do that. We get V1 equals 15 minus 8.18, which equals 6.82. V2 equals 8.18 minus 0 equals 8.18. And V3 equals 8.18 minus 0 equals 8.18. And these voltages are the same because they're parallel, right? Alrighty, so there are your voltages. That is V1, V2, and V3 using nodal analysis. Thank you.